Well, thanks everybody for coming to the Tool Time Talk. And so I'm Gary O'Neill. I've been in this business since 2003 as an auditor. I got in this business when my company got acquired by Microsoft, and they asked me. I was in charge of R&D. They asked me for the licensing information, and boy, did I learn a lot how hard it is to actually come up with these things. So I started a company that does tools and consulting in this area. And I've been involved with SPDX almost from the beginning, not quite. I think I joined about 6 months after the SPDX organization started rolling. But one of my roles in SPDX is I'm kind of the tool guy. I got started in it when we had a debate as to whether to do tag value or RDF. And those of you that don't know what it is, don't worry about it because the tools take care of all that stuff, right? But to solve the debate, I wrote a tool that translated between the tool, and then the needs kept changing, and I kept adding. And so now I've written a bunch of them that I'll be presenting a little bit later. So what we're going to do today is talk about the tooling. And there's several different presenters. Sameer is going to start off with what Wind River has been up to, and Sameer is one of the developers, has worked on the tool, so he's a good authoritative source on that. And I think what's important about Sameer's talk is it's going to go over the difference between a highly automated, quick run identification tool and how that affects the quality relative to a process that involves humans. And that'll kind of frame up, I think, some of the future talks that we're going to have on tooling, because they range between tools that are really intended for full automation, where you just push a button and it runs, and tools that are really to support more auditor approaches. So, for example, what I do in my business, I'm the human that's typically involved, or one of my auditors is typically involved, and there's tools to support that as well. Then Daniel's going to talk about Ninka. Daniel's a professor at University of Victoria in Canada. And Daniel's been involved more than I have, longer than I have, and has been providing a lot of really valuable feedback to the SPDX organization on license identification. So Daniel's going to share with you his experiences and the Ninka tool that does do license identification. Matt and his team from the University of Nebraska, Omaha, I think a lot of you are actually here today. They're going to go over what they've done with pathology and incorporating SPDX. Some pretty cool demos in there. I think you'll be impressed what those guys have done. Then I'm going to talk about the SPDX tools. And up to this point, everything is open source. So those of you that are looking for all the commercial product information, sorry to disappoint you, everything's open source up till now. But I did want to follow up with the results of a survey we sent out that said, please send us information on all the tools that you know of that support SPDX. And so I'll be going over the results of that. Not much detail, but it'll give you a feel and it'll give you pointers. So if you do want to know about commercial tools, there are actually quite a few of them in there that do support SPDX, and there'll be pointers for who to follow up with on the details, because I think if I presented it, it might have a little bit of a bias. So we'll leave a lot of that for later. And then this is called a panel discussion, but I think what this really is going to be is more of an interactive, collaborative discussion on where do we want to take tools next. So I definitely want to get all of your participation in that discussion, and all of the presenters will be up here, and we'll all participate as well, of course. So with that, I'm going to turn it over to Sameer. Just put that on. It's on if you want.
Ladies and gentlemen, my name is Sameer Ahmed, and I work for Windows System, and here's I will be talking about computer automation versus unit support. Before I go there, I would like to give credit to Gary O'Neill. He has developed a lot of tools, and it's posted on spdx.org, and he has done a great job. So here's my team. That's me, Sameer Ahmed, Mark Easy, he's my boss, and Lisa Sednero, Marila and Mihai. These are my team members. First of all, I'm going to be giving a brief background. What is a human analysis? So human analysis is, when I talk about human analysis, we mainly talk about human experts who are really well-versed in license identification. They go to every single file in the package, and then they identify the license. and I can say it is a high quality data. We have our confidence, we have a team at Wind River which does that and which has done a very decent and very good job. But while on the other hand, it is a time consuming job as well. For example, if you take a package such as kernel, kernel can have 36, more than 35, it has more than 35,000 files. If the human experts have to go through every single file, it's going to take a lot of time, and it can even take from 1 week to several weeks. So that's very labor intensive. But usually the work they have done, or usually the work which is done by human expert, is considered and categorized as a high definition. While on the other hand, we have a computer automation analysis, which is fast, but it's a little bit challenged what software development model we pursue in order to implement those one, and the quality can be marginal. There can be up and lows, and the quality improvement always present challenge. And usually it is considered from low def to mid definition. Here's our Wind River mission. Very simple. Achieve high definition via automation. There's nothing more than that. It's just automation, high definition. And here's my presentation goals. It's very simple. Yesterday we had a good discussion about SPDX, the way it's moving forward. Today I'm going to be just putting a concept of SPDX quality framework. It's just a discussion. We can just SPDX quality, how to improve it. Here's a chart. Mark already talked about this one. So this is quality time. Here's one of my default agents which is running as a roadrunner. It provides certain heuristics for certain heuristics from file, like the non-copyrightable, and it also does the license matching. So this is just simple. Over time, the quality improves. This is an approximation. So we have to shift the code. We have to improve the quality. How are we going to do it? So we have to shift it, and here's our destination. So this is going to be the first path. How are we going to get there? I'm going to show you. So here's one of another initiative within Wind River. It's an internal project. It's called zDarwin, and the main goal is to again improve SPDX via automation. But how is it done? Basically, if you have to explain zDarwin, it's an expert system which employs multiple intelligent agents. It identifies the strengths of each agent. The analogy would be, let's say we have superheroes. Everybody likes superheroes. We have Spider-Man, we have Batman, we have Hulk, Superman. They all have their strengths, and if we combine their power together, we can save the world. But here we are not going to save the world, we are going to improve the quality of the SPDX. So this is a very high-level picture. Here we have a scheduler in zDarwin, and it employs multiple intelligent agents, and these are more like a plug and play. We can plug it in the agents, we can plug it out. It's totally up to us when to plug in more of them. For example, we have agent 1, 2, 3, and 4. So in this particular example, let's say if we have a BusyBox project, it goes through every single file. It passes on this file to the multiple intelligent agents in parallel, and then we have an output from the intelligent agent. For example, in this particular scenario, I will be talking about Pathology and Ninka. They are great tools. So what really happens, like, first of all, the file.c as an example is passed over to Pathology. We have an output. zDarwin knows the strength of Pathology, what it is good at. So what it does, it allocates a certain weight to it. And then it also passes the same file at the same time to Ninka and gets the output. And it also knows the strength of the Ninka. So, and also allocates a weight to that particular file. So our voting algorithm decides which one to select and which one to ignore. So for example, another example would be Pathology is good at GPL detection licenses, and Ninka is particularly, on the other hand, is good at extracting license notices and also attribution style notices. So one way or another, different rate will be allocated to the output of these tools. Okay, here is another utility which we have built. It's called QTest. First of all, I've just paused and talked about quality. Quality matters. Our customer, we distribute SPDX, and quality matters to our customers as well. So in order to take it through a little bit, for example, I would say that QTest validates and compares computer-generated file against the benchmark. So let's say, for example, we already have a high definition file for the BusyBox, which has been done by our experts. So we are going to take that as a benchmark, and then we are going to compare computer generated against it to see how good it is. The example would be, for example, we have every student here, for example, must have done the SAT exams. So whenever the student writes, it's a test paper, and then we have an answer sheet. So the test is always compared against the answer sheet. The test is not compared to the test itself. So this is the knowledge. So I'm going to give you a very small demo. Furthermore, I would just say it also have rules, bit of a complex rules, which usually calculates the SPDX file quality index. So let me just go ahead. So here's a demo which I was able to build up for the zDarwin. I have let me just go back. I'm gonna upload a file, BusyBox. So I'm gonna here are many different agents we have. By default, we always select go run. Then I'm gonna select pathology and then perform. So it should be able to generate computer generated file. In the meanwhile, we can talk about the high definition file. This is a high definition which is available at spdx.windriver.com. You can have access to it. It is done by human analysis, as I've mentioned before. It has several license references. Some of you must be aware of it. Most of you, it is a customized. For example, if the license doesn't exist in the standard SPDX license list, it can be referenced to one. And if you just scroll down, you should be able to look at different I'm not going to go much in detail. Everyone has access to these particular files. No. Yeah. Yes. So what they did, they entered in our system, and the system was able to generate the high-def files. So they don't have to go through. All they have to do is just record the data and just put it in the system, so which we have. So the report has been generated for pathology agent. Now I'm going to go to the quality, SPDX quality index, to know the quality of the data against our benchmark, which is the high-def data. Let me just zoom out a little. Can you guys see? So here's, I'm going to be uploading first of all the high definition, and then the computer generated, and then here's a gauge which will just determine, which can calculate and say whether it's a low definition, medium, and high. So we have a pathology which was generated at 10:30. So here is the number we came up with, which is a 538. So this is the benchmark against the real high definition report. So this number is usually, we can say we have an algorithm which divides this. So for example, I have a slide for that one. I can just explain it to you later on this one right now. Right here. So what really happens, like, we divide all the licenses into 5 buckets, which is strong copyleft, weak copyleft, attribution style, license references, and others. So we already know what are the strengths, as I already explained it to you, what pathology is good at. So for example, let's say there's a GPL 2.0, which the tool pathology says exists in BusyBox 200 times. And then our analysis comes, our human analysis say that this is wrong, it has come up with 300 or 350. Then we have a rule, we say, for example, okay, this is the time, this is how much the GPL exists. For example, out of 350, it is 200 or whatever the figure might be. Then we have a value for the bucket which we multiply, and out of 1,000 we get. But this thing gets complicated when it comes to the composite licenses and ORs, because we then have to make a second pass through it, and we have to allocate, because we would like to give the credit for the person who comes up with and OR, because and is more like conservative, but OR is more like we have a choice. If you have more questions, you can ask me about this. So here's what we work with the Roadrunner. Yeah, this is the Roadrunner. What happened is now the curve has shifted. Pathology plus Roadrunner, the quality has improved over time. But still, this is the first time, the first pass. This is not where we want to get. We want to get right here. So we still have to shift the curve further. Now I'm going to include the Ninka into the process. I'm going to be doing another demo. I'm going to take the Pathology plus Ninka, combination of both of them, to see what the strengths are. So it should take a little bit of time, a little bit, not much, in order to do it. So what it does is, first of all, let me explain you. So when it comes to Pathology, it extracts the package, it uploads the package, it studies, first of all, it applies the heuristic knowledge to the package itself and the file, and then it has to upload the file itself to the Pathology scheduler in order to get the output for it. And then we have a local repository where we store this particular information. For Ninka, it's also interesting. We do execute the scripts on it, and whatever there are like certain files which are generated, we take the output and we utilize the information for it. So the report has been generated for Ninka and Pathology. Let's try it out whether the score has improved or not. So here's the Ninka that was generated. Yep. Now the file is mid-def. 581. There has been a shift to the curve. So Ninka has been good with the license references. It was able to, Pathology wasn't able to output the license notice itself, the data itself, the extraction text, but Ninka was able to do it, and we were able to utilize Ninka in that particular scenario. The other one would be the attribution style. We always preferred not always, but in most scenarios, the result was preferred, the Ninka result was preferred in the attribution style of that license. Now let me go back to the presentation. So this was the curve, this was the first pass, Pathology plus Roadrunner. Now we have a second pass. The quality has improved further. This is still the approximation. Ninka plus Pathology plus Roadrunner. So what we learned is 3 minds are better than 1, and that's true. So we have 3 geniuses together, we can have more quality data. But again, this is not the destination. We still want to go to high quality, low time. How do we do that? Here's the silver bullet. Mark gave a concept what silver bullet is all about. Now I'm going to be talking about the silver bullet agent. Again, I would like to just go back and say about the zDarwin. It's an expert system. It has many other agents, okay? So now I would like to plug in the silver bullet agent into it. What is silver bullet? First of all, I would just say it is highly efficient, highly quality data. It's a simple concept. It's just going to the file level and just tagging every file with the tags. What are the tags? I can talk to you about those ones. Now let me first generate the file with the silver bullet. Here's a PDF which has already been shown, but I'm going to further elaborate this one. So here is one of the examples. This is a mad.c, which is a very popular file inside the BusyBox package, and it has this particular tag right here, file license. The syntax, this is an open-ended discussion. I mean, I totally believe that the syntax can change later on. But this is just a concept we are just putting forward, that we can have a file licensing tag in every single file. Let's say over here, for example, we have a GPL 2.0 and BusyBox, 3Cross, and MIP. And then later on, it's according if the developer wishes, then the developer can have a license notice himself. So we have a tag license notice, name, BSG 3Cross, and then we have a license notice right here. And it would be a piece of cake, I believe, for any developer to just extract these particular license notices and generate a reliable SPDX code. What do you mean by that? can just be, I mean, these are the optional. It can just be the GPL 3.0 tags. For example, let me just go further down. Yeah, that's an optional. Yeah. These are absolutely optional. So we have a tag for license notice 2.0, and one other advantage would be that it can be at any part of the file. It can be at the footer or the header. It doesn't matter. Now here we have an example for the MIT right here, and here's the license notice in between. Again, these are optional. Yes. And by the way, I would just say that we have like high-def data for more than 800 packages, and furthermore, we are already in discussion to update our coding standards to include these particular tags in our commercial clients. So here, okay, again. So you're referring to the silver bullet concept, right?
Yeah.
So silver bullet is more like it also utilizes, for example, when the code is first. The main concept is when the code is first being written, it uses the developer intelligence to write these tags. The developer, if the developer knows how to write the tags, it's just very simple, just file licensing, and that's just the license name. If the other part is more like optional, if the notice has to be in the file. But it's mainly just a license expression at the top. It can be anywhere in the file, whether anywhere like comments or anywhere in the file, so it doesn't matter. But it's just the tag itself which matters a lot. Absolutely. Yes. So what we do is right now. So we had the high definition data for the BusyBox. What we did, we write a script which injected into the source file, and then we were able to extract it. This is just demo right now, and then I'll compare the quality. Yes. still trying to update the coding standard for the new projects with us. Yeah. Okay. Again, I said that the zDarwin would be able to resolve that situation. The zDarwin knows which okay, we have looked at many scenarios. We have studied many packages for physiology, the output of physiology for those packages, and for the Ninka. So we know which what are the superpower of physiology. We know what are the superpower of the Ninka. So we then, for example, if there is a conflict, we go with the rules which we have determined whether which physiology is good at, whether physiology is good at GPL 2.0, detection of GPL 2.0, or GPL like LGPL 2.1, and the Ninka is good at VHD detection. So we go with what we have, what our analysts have researched and what we have improved. This is also like an incremental approach. We would, as we go through more and more packages, we have like the research just expands. We have more and more rules into it. We know what are the advantages, what aren't, because every license node is different from other. There's no such order. It can be performed any way possible. But for the sake of demo, it's physiology, Ninka, and it also depends how the software has been developed. It can be other way around as well. It can be physiology first, Ninka second. So it totally depends on which way it is. So I believe it can be done. So okay, finally the report has been generated for Silverbullet and sorry? Okay, with Silverbullet we have a high def report. Okay, this is not gonna. Okay, I'm gonna explain you why it's not 1,000. Yeah, yes, some of the developers did not. Yeah. Yes, we did. We did it. We could have got 1,000, but there are some of the files which doesn't have the tags in there. So we just wanted to. This is a concept, I believe, that the result can be other than 1,000. We don't have to expect with Silverbullet it's going to be always 1,000. So for this exercise, it's 905 because some of the tags are missing from the files. So Silverbullet was able to detect those particular tags, and it came up with this particular high definition. So it's in the green range, and as you can see, it's 905 out of 1,000. Absolutely, you're correct. One other thing I would like to mention. If, for example, we have Silverbullet plus Ninka plus physiology, it's going to be even more higher. That's the more concept. Because one other thing is that if there are no Silverbullet tags inside the file, it's going to go to the alternative, which is going to be the physiology second pass and the third pass. It can first refer to Ninka or physiology or any other tool to out there. Silver bullet is, yeah, exactly. It's independent of SPDX. It can have its own specification out there that can be released to how to type file and how to educate developers. Yep. Exactly. Mark already talked about the approach. So he just introduced the approach. I just introduced the agent, how it can be implemented. So here again, quality versus time. Here was the first pass Roadrunner, then the pathology plus Roadrunner, Ninka plus Roadrunner, and finally the destination. We have Silver Bullet right here. Okay, Roadrunner is a default. It's an agent by default. What it does is actually it's internal. It's our internal implementation. Right now it's not available, but it will. I can definitely make it available. One other thing is that it's also very, very useful for our analysts. They don't have to, for example, if certain heuristics is so for more information, okay, once in my conclusion, I would say I will want to promote discussion about around experience quality framework. This is what my presentation was all about. You can contact my email address sameer_ahmed@window.com, and you can also visit spdx.window.com. And finally, for our customers and for ourselves, quality always matters, and we are going to strive for it. These tools, for example, the zDarwin is still not. I still have to put it online, but it's going to take a little bit of time to do it. But soon, yeah, it is planned, and soon it's going to be available at xpdx.window.com.
zDarwin was that was the first one that you compared.
It's a framework. Yeah.
Our goal is also not to be in the agent business either. We're helping other people do better agents and this is the framework. But we do want to make it. I think we're talking about possibly using quality check. Take that out. We'll have a high def score sheet, right?
Yep.
Answer key, and then you can upload their machine code and get a score out. And you could also score.
Yeah, we would like to promote this idea of zDarwin on also the Q test, and I think they should be available.
Okay, I'll just do it. I should take it
You have any questions? I'll pass it on.
All right, thanks, and I'll just pass it right along today.
Are you recording this?
Yeah, it's recorded. That's why.
Oh, yeah.
So this is not a SPDX tool per se, but I think that it is important to the standard. And we have well, let me actually talk a little bit about Ninka first, and I'll talk about that. 4 years ago, I was doing sabbatical in Japan. So Yuki Manabe started to work on this with me, and most of the code is actually written by me. So I am the one who's doing the maintenance. He's now a professor in Japan, and one thing that is very important is that we have been very transparent with this. So you can find a paper, email me, and I'll send you the paper that describes exactly how we do it and how we have conducted evaluations of that. So a few years back, I met Bob Goviel from Fossology. And I got very interested in this, and because one of the areas we have been working on as a researcher is trying to find interesting problems in licensing. And one of them was there was lack of clarity in terms of even what are the licenses that exist. We get an annual report, but we don't really have a methodology. And so for us, it's very important that we say this is what we say. This is reproducible. We give you the methodology that we use. And so to be able to do that, we needed license identification tools. And Fossology a few years back, it was extremely slow. I'm talking about that it would take a minute in one single file, and in my computer. And an HP just threw hardware on the problem, right? And so that's actually why they have the architecture that they have, because essentially they just farm it out to many CPUs. But I had only one computer, usually my laptop. And I talked to Bob about some of the ideas that we had, but Fossology is really a huge infrastructure that is also user-friendly. And there's a lot of investment on that. And we wanted just to work at the license identification level, particularly the file. The file is really what we have been interested in. So one of the things that I really wanted to do, I wanted to sacrifice recall. So the fact, in our studies, between 15 and 20% of the files, we throw the towel and we say, I don't know what the file is. And but if we tell you what the license of the we don't know what the license of the file is. But if I tell you, or Ninka tells you a license, it's fairly accurate at what that license is. Usually our main error is that we don't identify all the licenses in the file. And because we don't know actually how many there are to begin with. And we also wanted to support I don't know. At the time, Fossology gave always an answer. And we felt that it was important to say, I don't know, the three-value logic. And so we wanted, of course, to focus on the most common licenses, and but be able to extend it. And it's a very simple pipe architecture. It's really composed of a bunch of little tools, and each one of those does one thing very specifically, so we can actually replace them with potentially better ones in the future. Yeah. Yeah, so now for exactly. Yeah. Yeah. And I think that this is the nice thing about the innovation from my point of view as a researcher, because I'm not in the business of doing consulting, is that when we did this work, I think that we put a little bit of pressure on Fossology. And Fossology implemented some of these ideas, and it was also part of the move to Nomos, the Nomos architecture. And so I think that we have been helping each other in this sense. And my goal is that in the future, they become almost one. So maybe there will be a way in which we can integrate both. So these are actually the steps that I do. And I think that, so I really want to talk about the steps, because a lot of people concentrate on the license that we output, but we generate a lot of very interesting, valuable data that most people might not be aware. And so the first thing that we do, we have to extract the license statement. Originally, we wanted to find comments. Parsing comments is extremely difficult. And so we just throw out the towel, because also you have to maintain parsers for every potential language that you want to support. So now what we do is we just take the first 800 lines of a file. Okay? And that means actually that we miss the licenses when they're at the end of the file. And there are some cases where they occur. I don't think that that's the case with Perl. There might be actually a lot of files with that. But yeah, but that happens, okay? So the next step is that we actually have to do text segmentation. Our algorithm relies on the fact that we can break all those comments into sentences. And that's actually also a hard problem to do, because in many cases, what exactly is a sentence break when you have consecutive lines? And that's actually one area where our method breaks very easily, if you have somebody who doesn't really have nice spacing between sentences. Then we normalize text. That's actually applying the rules of matching that we discussed yesterday in SPDX. And then we do sentence filtering, which basically we say, is this sentence something that has legal terms? And we have some heuristics that we apply. And then we separate them into sentences that they are legal, and we throw away everything else. So at that moment, you actually have the license statement of the file. And so you can actually use that for other purposes. And then the next one is the sentence token matching, which basically means that we have rules that match sentences to what we call tokens. And then once we have the tokens, then certain sequences of tokens become licenses themselves. So here's an example. So this is actually the license as it appears in a file. And then this is actually the break that has been already normalized and segmented and normalized. You can, for example, see how quotes, we replace them with something special. And because quotes, as I was mentioning yesterday. No, this is just to display, because they're actually much longer. And then this is actually the way that we turn it into what we call the tokens. And one thing that I was actually mentioned yesterday in SPDX is that you want to keep the information that is variable. You don't want to throw it away. So in this case, you can actually see that what we call the BSD warranty and the BSD as is, they have similar but not identical sections on that, which is actually part of what the license specifies. And then once we actually have this, then we can say this matches the BSD2 rule, and we throw away the all rights token, because that actually doesn't add to it. So we output that is a BSD2 and that there are no other sentences that we are not able to match. So if you look at the output of Ninka, it outputs a lot of extra information that most of you actually have no idea where it is, because I've never documented it. So it tells me how many sentences are not matched, for example, because it tells me actually where I'm having a little bit of information that might be part of another license, but I already matched one. And so for most of you, you assume that that's actually a license. There might be something else there lurking. So that's why it will be actually very useful. So it's in GitHub. Actually, there are two projects here for licensing that I maintain. And the other one is provenance of Java code. So that's a completely different story. So what about the SPDX? Well, we support some. So we don't support the names of SPDX because we think we are better than SPDX at BSDs. So if I start reporting BSD4, that actually, the SPDX is a subset of what I consider SPDX4 and what you will consider an SPDX4. So the names that we use is SPDX BSD2, SPDX BSD3, SPDX BSD4, SPDX MIT, etc. So that might change over time, and but that's just currently the way we do it. Until SPDX templatizes some of these licenses, I don't think that will change. So the best thing is probably just to have a translation table between the licenses. It's AGPL version 3 plus, and it's also command line. And a lot of people actually ask for something better. So unless somebody actually forks money to hire a student to do that, it's not going to happen. And because it's doing exactly what we intended for. Is it maintained? Yes. So every time that I find new licenses, I add them. And if somebody, I have actually received only contributions by one person in terms of new licenses. And yeah. So in terms of new features, I don't think that we will implement a probabilistic approach like Fossology does. I think Fossology is very good at doing that. And I guess the biggest question is whether and when we will move to SPDX name approaches. One of the things I really like from SPDX is to have namespaces, so I can actually use my own license names and in the output files. One thing that I really want to do is I want to actually help Debian, and I was talking to about talking with some of the Debian people in trying to generate this PDX for the packages and doing a census of licenses, a proper census that says this is the methodology, this is the corpus that we use. If you choose the right corpus, you can say anything about licenses that you want. And but if you agree in the methodology, then anybody can actually go out and then test it or do it in another corpus. So I think that will bring a little bit of transparency. That's actually work that we're trying to do also with OSI, that they want to understand how the licenses are used. The other thing that I would like to from the SPDX people is to give me examples of how some of those licenses are used in practice, because if I don't see them used in practice, I cannot detect them. There are many licenses in the standard that I have no idea how they appear in files. Because remember, I don't identify licenses, I identify the use of the license within the file. So in many cases, the reference. Okay. And I think that's actually my last slide. Yeah. Yeah, so remember that we have a pipe infrastructure. We output to standard output. You can create any filter that you want and translate those names to whatever you want. Not so far. Yeah. Yeah. So let me revert that. It will add a lot of value if people actually send me a letter from your corporations telling me that you're using Ninka. Okay, so I need actually, I need a little bit of incentive to actually move forward. Okay, and so because I have that table for 20 licenses, and I have it in the scripts that I use to generate SPDX. For example, the BC box and the time for tomorrow. And but it's not part of Ninka because it's not really part of Ninka, so it's not really part of that. It might actually be just a side project that just says this is just the filtering of the output of one translating to the other. Okay, and so I think that there are a lot of small things. This is something that anybody can take. This is something that you can create a GitHub repository and just create that filter. And so I think that, and it's not difficult. It's actually just a matter of sitting down for an hour, looking at the license we generate and trying to do the matching. And so I want to actually see more collaboration with the Ninka. And so, for example, if you make modifications to Ninka to be able to actually match what you have, just send them back, right? And yeah, so that's more or less the status. So my view now is that Ninka does exactly what we need to do the research that we want to do. And it has usability problems, but I don't have the money or the time to deal with them. If people want features, then give me money to hire students to actually do them. And that will happen, right? And except with HP. So I'm very interested to actually work with HP on trying to improve the tools, because I also feel that HP is giving a lot back to all of us. So for a lot of the companies and the individuals that they basically are just actually doing the consulting, I need to see that there is involvement too. So like this mutual collaboration. We support around 20 or 30. I actually know we support like 100 different variations of licenses. Like MIT, so we have like 12 different variants of MIT, something like that. And so if you consider actually the BSDs, the SPDX style with the exceptions, we're even better than the standard because GPL version 2 with Bison exception is in SPDX, but GPL version 2 plus with Bison exception is not in SPDX. Yeah, so there are a lot of licenses. We detect what the fuck, we detect beerware, we detect zlib, and there are a lot of them. And but it's also extensible. It's not trivial to actually extend. There are some hacks that we have to deal with respect to greedy matching that we were talking about yesterday. Greedy matching is very problematic for license identification of some of them. But yeah, so we do a fairly good job with them. But I think that Fossology probably detects more licenses overall, but we detect more nuances of some of them, like the MITs and the BSD were more accurate at that. Yeah.
Thanks,
Yeah.